Engine vibration measuring instruments. 1. Vibrometer, vibration meter. Description: a handheld instrument that measures vibration amplitude, frequency, and acceleration. Working principle: uses a piezoelectric accelerometer to convert vibration into an electrical signal. Output: displacement mm, velocity mm/s, or acceleration m/s superscript 2. 2. Accelerometer sensor. Description: a sensor that directly measures acceleration due to vibration. Use: often attached to the engine block to monitor real-time vibration data. Working principle: piezoelectric crystal generates voltage proportional to acceleration. Output: electrical signal analyzed by a data acquisition system. 3. Vibration analyzer. Description: advanced instrument used for detailed vibration analysis, frequency spectrum, FFT, etc. Use: identifies specific causes like unbalance, misalignment, detonation, or loose mounts. Features: frequency spectrum analysis, trend monitoring, fault diagnosis. 4. FFT, fast Fourier transform analyzer. Description: converts vibration signals from the time domain to the frequency domain. Use: helps pinpoint vibration sources, e.g., crankshaft, piston, valve train. Often integrated in vibration analyzers or software systems. 5. Laser Doppler vibrometer, LDV. Description: a non-contact optical instrument that uses laser beams to measure vibration velocity and displacement. Use: laboratory or research applications where precision is needed. Advantage: no physical contact, ideal for rotating or hot engine parts. 6. Data Acquisition System, DAQ. Description: a system that collects and stores vibration data from multiple sensors. Use: long-term vibration monitoring and analysis on engine test benches. Often includes software for waveform visualization, FFT, RMS, etc. 7. Proximity probe/eddy current sensor. Description: measures the vibration of rotating shafts, especially in turbine or large engines. Use: non-contact detection of shaft displacement. Output: voltage proportional to shaft movement. 8. Condition monitoring system. Description: integrated system for continuous vibration monitoring in industrial engines or turbines. Components: sensors, accelerometers or proximity probes. Signal processors. Software dashboard. Use: predictive maintenance and fault diagnosis. Thanks for watching my video.